Welcome, welcome. Alrighty, let me share my screen. Yeah, I think AirPlay is what I want. Share. Why are we moving so slow today? Awesome. Make sure you guys are all muted, please. Alrighty. So you can hear someone is not muted. Does someone have something to say? All right, can everyone hear me?
Yes.
Great, thank you. Okay, awesome. Muted the person that had their mic on because they were not listening anyways. All right, great. So you're fine, Griffin. I am a little sick right now, so I'm a little grumpy and I'm sorry. I have a stomach flu and my tummy still hurts. Okay, cool. So today, we're gonna be hopefully finishing 8.1, 8.4. It will be finished. And then we will do B.2. Thank you, Gabby. And hopefully maybe B.3, but I'm usually pretty ambitious about our to-do list. A few announcements first. Homework 1 is going to be available tomorrow. The homework that's on website right now is just a practice one, or that's just for you to like kind of practice what we did last week and who assigns homework on the first week of class. That's rude. I'm not going to do that. So I just thought we would cover it and just call it our practice homework. Get used to how to homework 1 is due. That is what I always forget. Homework is always due the following Thursday. Let me put my to-do list down here. Okay. Oh, geez. Exam 1 came with it. So this is going to be due next Thursday at 11:59 p.m. On Blackboard and on website tells you that's a reminder. Homeworks are always due the following Thursday, so you have a week to do it. And yeah. So remember, part A is on WebAssign, part B is on Blackboard. So under assignments, you'll see homework 1, part B, and it'll have like, please do these 5 questions from the textbook. Handwrite them if you want to do, if you have opportunity to do something how I write notes on an iPad, you're welcome to do that. But I beg you to turn it in as a PDF. I don't want JPEGs. I don't want live photos from your iPhone. They turn up as movies and I can't see them. and make it one PDF. Like, so like if you have like take a picture of each one of them and transfer those all into PDFs, try to combine them into one PDF. If you're able to do that and just turn one singular PDF in, I will reward you with 5 extra credit points on exam 1. So there's an incentive of you to try to do this. JPEGs take so long to load, they're just a mess. And a lot of the times, students do not name their JPEG, so it's just a bunch of letters. And when there's like a 15-page exam I have to grade, I don't know what question to grade. I grade it by question. So it takes me a few hours longer to grade. So if you're handwriting it on paper, what I do with my handwritten homeworks is I use this app called Adobe Scan. I've talked about it a few times, and it will take a picture of your document, and then you can like align the corners and get it to work. And then you can add another picture, like the second page of a PDF, and then like email it to yourself and download it onto your computer. And then there you go, you got a PDF that you can turn into Blackboard. So that is a great way. If you want to turn in your homework a day early and you're like, Mackenzie, is my PDF, did I turn my PDF in right? I'll go look at it really fast and be like, yeah, great job. If not, then I think you can resubmit it. All right. So the homework 1 will cover everything that we've covered on Tuesday. So A3, A4, and everything that we covered today. That's why it is assigned tomorrow, because I don't know what we're going to get through today. Okay. Any other questions about homework before I move on? Great. I think I've kind of already went over our to-do list. We had a few examples in A.4 to go over, and then we're going to go over B.2 and B.3. All right. So I think we're going to go to A4. Remember A4, we talked about radicals and rational exponents. So we talked about a square root, a cube root, and an nth root, and how to handle those. And then a little bit more in depth if I have a rational exponent. I just had 1 over n last time, but now this is like 2 numbers, another number over another number, and how we can do it. It's usually best to take the nth root, excuse me, the nth root first and then to the n power, just because it's easier to make a smaller number smaller than bigger. And you can see that when we did this, if I cube 9, I don't know what that is, and I definitely don't know the square root of it, but it's easier to take the square root of 9 than cube it, all right? And then when we take even roots, we have to remember our plus and minus, all right? If I have an even root, I'm gonna have an even number of answers. All right, cool. So that was working with numbers. Now let's work with letters and numbers, variables, we also call them. So you're okay, bud. We have a to the 1/3 times a to the 7/3, right? If they're just right next to each other, we assume that's multiplication, even though there's no like dot. So how can I simplify number 1? This also would go back to A.3. I would add exponents. Absolutely right, Griffin. Thank you. All right, so I do like a 1/3 plus 7/3. And that's going to equal 8/3. Since the denominators are the same, I don't have to worry about getting a common denominator. I already have one. And I just add the numerators, which is really great. Awesome. All right, cool. Here, let me put a box on that. I'm sorry. I don't know why Duke sleeps all day and then class time comes and he's like, I'm going to play with my loudest toy. Number 2. So I have 4 times a cubed times b to the 4th that quantity to the 3/2, right? So what can I do to simplify this expression? Give you guys time to type if you're typing anything. So multiply the exponents. Yeah, I understand what you're saying. Thank you, Tucker. So am I going to be multiplying 3 times 4? I have 3 different exponents. Technically, I have 4. 4 has its own hidden exponent of 1. Duke, go to your crate. Or just like chill. Yeah, I want to multiply the inside exponents by the outside exponent. 3x, 3/2. Oh, 3 times 3/2. Okay. Right, that's one of the multiplications that we're going to do. So I'm going to have 4 to the 3/2, a cubed to the 3/2, and b4 to the 3/2, right? Distributing that exponent. And when I do that, we learned in 8.3 that I'm just going to multiply these guys. So, which I think that's what Tucker and Griffin were saying. So, 4 to the 3/2 is plus or minus 2 cubed. We'll come back to that. A to the 9/2. And then b to the 12/2, which is also just 6. All right, and then I'm going to finish this out by cubing plus or minus 2. So that is going to be plus or minus 8. Yeah, a to the 9/2, b to the 6. Great. How do you guys feel about simplifying these expressions so far? Thumbs up, thumbs down, or thumbs sideways? I got 1 thumbs up, 2 thumbs up, 3 thumbs up. 9/2 comes from 3 times 3/2. When we see something like this, we assume it's like same as saying like 3/1 times 3/2. And when we multiply fractions, I multiply top times top and bottom times bottom. Sideways, sideways, sideways. Okay. I will warn you guys when you're doing your homework on this section that sometimes WebAssign isn't so stingy about plus or minus. It'll ask you to put like 2 different answers if there is one. But if there is not, if they don't ask you for 2 different answers, because plus or minus isn't a thing on WebAssign, go with a positive one. Just on WebAssign. That's just their thing. Because I don't think the textbook has necessarily brought up that square roots and 4th roots can have a plus or minus. So just be wary. Okay, so moving on. Now we have 2 times square root of x, the quantity times 3 times the cube root of x. So now I don't have any fraction exponents, rational exponents, like I had in the last 2 examples. Now I have radicals. So what's a fun first step that we can do? Ask for help. That's fine. Is it going to be easier to, exponentialize, right? There's not really a word. I would transfer my radicals into exponents. So there's your help, Tucker, from Abby with the assist. right? So if there's not a number on the radical, remember we assume it's a square root, which is just 1/2. And 3x to the 1/3. It's kind of, in my opinion, redundant that these terms or factors are in parentheses because it's not too much different than what they're saying, right? So when I multiply these two things, I can just drop the parentheses. So I'm going to have like 2 times x to the 1/2 times 3 to the x to the 1/3. That's like the same thing. They're all being multiplied. The x looks really sad. Ding, ding. Right? And now I'm going to combine like terms, or I'm just going to put them next to each other. I know, I'm so sorry. It's actually a cat toy. It's Winston's favorite toy. It's a little mouse that squeaks, and Duke really likes it, and I'm sorry. Okay, so I'm going to put all these terms together or next to each other. It usually helps me out when I want to combine them. Great. Well, I know 2 times 3, that one's pretty fun. It's just 6. What about x squared? Not squared. X to the 1/2 times x to the 1/3. Come here, bud. How can I combine those two? Bases are the same. What do exponents do? I could find a common denominator first. Why do I need to do that, Ronald? Right, because I want to add the exponents. Exactly. You guys are on fire today. Right, I want to add the exponents, but before, to do that, I need to find a common denominator. Perfect. Great answer. So plus 1/3. So we're going to keep here. Let's go. Oh my gosh. What's a good common denominator? Sorry, dropped my phone. For 1/2 and 1/3, right? 6. So 1/2 would turn into, I think this one we can do pretty much in our head. 3/6, right? Plus 2/6. When there's a 1 on top, you can just kind of throw that up on there. Right? And now it's going to be easier for me to combine denominators. Okay. Duke, drop it. So then bases, not bases, denominators are the same, so I can add the top, so I get 5, 6. And we're good to go. So this one was similar to number 1, where I just had bases are the same. I add the exponents, but I had to do a little bit extra wiggle work to get there because I wasn't so fortunate to have the same denominator. You can see where it's all building up on ourselves. Oh my goodness. Okay, 1 second. I want you guys to try number 4 on your own, and then I will come ask you guys. So I'll give you guys like 2 minutes to work on that, and I'm gonna go take this toy away. Okay. Squeaky toys have been confiscated. So how are we feeling about number 4? Abby's feeling good. Does anyone need a little bit more time, or do you guys want to discuss it now? That is a valid emotion, Jared. Okay. Abby was feeling good about it. So Abby, would you care to tell me what you did first? Tuka's wandering around looking for his mice. I would also turn my radicals into exponents. So notice that this radical is under this radical, right? So it's going to kind of look something similar to 2, right? So Abby, did you write something that like x to the, or x times x to the 1/2 to the 1/2? Okay, beautiful. I just knew that was going to be really difficult to like type out, and that's why I didn't want to ask you to do that. In the real world, I would have gotten you to write it on the board. Okay, cool. So something like that. My God, my handwriting today. And now we're going to do what we did in number 2. And I really actually don't even need, actually, no, I'm going to keep this. So actually, Abby, what did you do next? Because there's one of 2 ways that we can do. Okay, yeah. So you can distribute the outer 1/2 first. So I get x to the 1/2, x to the 1/2, and that again is to the 1/2. So then what? X to the 1/2. 1/2 times 1/2 gives me 1/4. Great, thank you. And then I'm going to add those. So I get x to the 1/2 plus, oh, not 1/2. I don't want 1/2 anymore. 2/4. So I can get my common denominator, which is 4, plus 1/4. So I get x to the 3/4, right? Yay! Thank you, Abby. Another way we could have done it is I could have combined, I could have worked on the inside first. So x times x to the 1/2 to the 1/2. I could have x to the 1 plus 1/2. Oh my God, what is that? There we go, 1/2 to the 1/2. So kind of done this last step first by adding the exponents. And then what? X to the 3/2 to the 1/2, and I multiply them and I get 3/4. 2 ways to do one problem, and both of them are absolutely correct. That's the fun way of when you are shown and can fully understand the ins and outs of why these things are the way they are and why I can distribute and so on. You can do a problem more than one way, which is the best part of math, in my opinion, and why I love mathematics. All right, so we're gonna move on from exponents and talking about it. Ignore the Socratic thing that was under it. But how are we feeling about radical exponents and all? Thumbs up, thumbs down, sideways. Nice. And also, if you like aren't feeling very thumbs downy and you don't want to tell me, you can always like private chat it to me and I can still see it. The last one is in the textbook, so it's a textbook problem 2. Maybe I'll sign up for homework. But yeah. So if you're not understanding all of this now, if you're like sideways or down, just totally fine. That's what the homework is going to help you guys with. And still, like during the homework, you're like, I'm reading the textbook. You're like, no, not getting it. I have office hours. They're on my syllabus, and I have MTC hours. So I'm available 4 hours a week. And then you can also schedule more time with me. All right, cool. So we're going to move on. Oh no. Did I do it wrong? Hold on. Rational expressions. Factoring rational expressions. Hold on, I think I named things wrong. Actually, here, I can figure this out really fast. Okay, no. Factoring. Okay, so this is B2. It's not rational expressions, it's algebraic. I had B3 types up and not B2, and it messed me up. Okay, great. But I got the date right. Okay, cool. So factoring, if you don't remember what factoring is, we use, oh, son of a biscuit. Where are my notes from last year? There it is. So we use distribution to expand a polynomial, right? So if I have something, let's say, like x minus 2, x minus 2, right? I'm going, or x plus 2, excuse me. That's going to equal, after I FOIL, which is what we all are kind of familiar with, first, outer, inner, last. That's what FOIL stands for. It's x minus 2. I would get x squared minus 4. So going this way, we would call expanding. But if I wanted to go from this way, I know it doesn't look expanded, it looks shorter, but like, bear with me. If I wanted to start on the other end and go backwards, so x minus 4 and go this way, I would call that factoring. Because each of these two things is a factor. Two things multiplied together, factors, things added together are terms. Fun fact. So the reverse, we call it factoring. And I like to pose the question, why is it useful? Why is it useful that we factor? What's the point? So what are some ideas of the usefulness of factoring? Right, because we can find zeros, right? If I have x squared minus 4 equal to 0, okay, that one's kind of easy to solve. But if I have like x squared plus 3x plus 2 equal to 0, I can't like get x alone and solve for x right there. That's kind of hard to figure that out. Yeah, it's a lot easier to look at and solve, but oh, is this even a thing? Multiply to 2, add to 3. I think it's like x plus 2, x plus 1. Okay, that's right. That I can tell you really quickly. It's going to be like x minus 2 and x minus 1. So that's the usefulness of factoring. It helps find zeros. Does anyone know another word for finding zeros? Or zeros? Zeros, that doesn't have any. It's an intersection with one of the axes, but they're also called roots. It's like the root goes into the ground right as it intersects with the earth. So the roots, finding roots. So I ask you to find the root, you're finding the zeros, okay? I know we just talked about square roots and cube roots. roots. I don't know why lots of things in mathematics are called the same thing and mean totally different things. Okay, so the first way, there's lots of ways to factor. There's so many ways to factor. You actually can't factor any polynomial directly if it's like greater than like 5. I think there's no direct way to do it. And that is what my field of study goes into, about how to like do that. It's a lot of like machine work and it's pretty cool. All right, cool. So factoring out common factors. That's our first way that we're going to factor. So I'm going to do this one and then we're going to talk about it. So I have 6x squared minus 3x. Well, each of those, I'm looking for common factors. So remember, factors are things I can multiply together. So I have 6x squared, and let's keep a minus on that 3x, right? I can call 6x squared 2 times 3 times x times x. That's all of its factors. And then negative 3 is like negative 1 times 3 times x, right? So I see that each one of them has a 3x that I want. So I can pull it out. So 6x squared minus 3x turns into 3x times the quantity. What's left over? 2x minus 1, right? So each term, right, they're separated by addition and subtraction, same thing. So these are terms, and then a factor is something multiplying it. So whatever it's multiplied by, it's a 3x each one of them has in it. Does that make sense? Okay. This right here is just a fun way to like kind of decompose each term, right? So in the above example, 3x is called the greatest common factor. It's the largest thing that both terms have in common, or they share, right? Factoring out common factors is really helpful to use when finding roots of like everything, every coefficient's like an even number. You can pull out a 2, something like that, something fun, right? So we're not really going to do much on that. Now we're talking about factoring by grouping, which is a little, I think it's fun. So we can factor some polynomials by what's called grouping. It's supposed to be an O. And pulling out the greatest common factor. So we group them together. Like I say like 6x squared minus 3x is a group within another polynomial. There are other things added to it. Group them together and then I pull out their common factor, right? It's best to do this when we have 4 or more terms. And then you have even groups and it's cute and fun, right? So we're going to factor the following expressions using grouping. So the first one I will do, we're given x cubed plus x squared plus 3x plus 3. In the beginning, it's going to be safe to assume that I'm going to be grouping things with the thing that's next to it. So let's group x cubed and x squared together and 3x plus 3 together. So what's that going to look like? I have a 3x plus x squared in parentheses plus 3x plus 3 in parentheses. And those are my groups. So the parentheses aren't meaning a multiplication here or anything. I'm just kind of denoting my groups in the parentheses. So now I can look at each parenthesis Let's make them fun different colors. I have like a nice blue. Can we see that? Yeah. And then is this a green? Too similar. Ah. Okay, great. So I have my blue group and my green group. Abby's so excited, right? So I'm going to look at my blue group first and see what it has in common. Each one of them has an x squared in it. So I'm going to pull that out. X plus 1. And then 3x plus 3, only thing I have in common is a 3. X plus 1. Well, now I have two terms, right? I have this big term and this big term. So now I can think of this as its one big group, right? The whole polynomial. What is the greatest common factor out of each of these terms? X plus 1, right? So if I pull out x plus 1 from each term, put like a bracket there, I'm going to be left with an x squared in this term, plus I'm going to be left with a 3 in this term. And I can make those brackets, parentheses, just to make everything look a lot nicer. And it's factored. And we'll get to know more about why it's factored. And now I know it's factored. I think in the next section. So how is this example? I don't want just Ronald and Abby to be talking if someone's sitting there kind of confused. So I hope if everyone participates because it's not fair. Someone's sitting there confused if I don't know you're confused. I can't see your sun-shining faces in class. Okay, great. Thank you. So we just factor this trinomial, whatever. It was polynomial in 3 steps, which was pretty fun, right? Grouping is a little confusing, but it does take practice, and that's what homework is for, and what class time is for. So what if we don't have x and 3 and x squared and something like something, right? Example 2, we're just given a times w plus b times c minus bw minus ac. First example, I could just group the first ones together. Great. They had something in common, and that was really useful to me. But these don't. So if I group together, oopsies, AW plus BC, and then I'm going to keep them. Be careful with that negative. When I group these things together, AW, BC, everything's different. So what's another grouping I could do? How can I rearrange this to maybe help plot some groups? AW and BW, right? So I can do AW minus BW plus BC minus AC. Right? Just make sure you're not just switching this, I'm taking that negative along with BW. All right, so now I can have AW minus BW plus BC minus AC. Same thing, I just have written parentheses to group them together. Okay. And I could also have done AW with AC minus negative AC as well. I could have done it that way. Similarly, I could have done my grouping up here differently as well. There's not one way to do it. But there are ways that are going to be a little faster and a little less strenuous. A shorter hike up the mountain, if you will. So this first group, AW minus BW, what is the greatest common factor in this group? Right, it's W. Each one of them has a W. So pull W out and I get A minus B. What about the last one? C, right? B minus C. Well, now my terms, I don't have a common factor. I have A minus B and B minus C. So what are some ideas? I can pull out another factor of something else. Oh, not B minus C. I meant B minus A. There we go. Thank you, Abby. So what can I do? I can't pull out right now. I have A minus B and B minus A. Those aren't the same things. I can pull out a -1. I like to, let's keep A minus B. So I can do W, A minus B. And then I can do like plus C times a -1. So when I pull out that -1, it's just going to switch the sign of everything. Multiplying by a -1 and dividing by -1 are the same thing. So this B is positive, so it becomes a -B plus A. So W, A minus B minus C, right? -1 times C, it's minus C. And then I can write minus B plus A as A minus B. Ding, ding, ding. Someone sent me a meme on Instagram. I have a greatest common factor. So it wasn't a little intuitive. I think maybe if I had, I don't know if I could have pulled out a -C because B, C, yeah, I don't know. There might have been another way where you could have just already automatically had that negative pulled out, but I don't think so. Oh, we're not done yet. We haven't finished. Did I put over the box for the last answer? Box. So how can I finish factoring this guy? Right, I can pull out the A minus B out of each term. So A minus B. Oh, okay, it wasn't working. So what's gonna be left over? W times A minus C, so I'm gonna be left with W minus C. Great. And that is our final answer. How can we check our answer? How can I like double check and make sure I got it? All right, I can multiply and FOIL. We already factored. but we can FOIL. All right, cool. So that's how grouping works. And kind of why we do pulling out common factor first, because it's part of grouping. All right. So how are we feeling about grouping so far? Up, down, sideways. All right, cool. Yay. So now we're going to talk about the AC method. My class last semester had beef with this method. If you know how to factor and you have your own way to factor, I know some people do this like cute little cross thing with like all these dots. I don't understand that. That's fine. This is another way to do it, that if you don't really have a method that you really like, this is another way to do it. It's called the AC method. So if we want to factor this polynomial, so I have a x squared plus bx plus c. So a, b, and c are 3 random numbers. X is my variable. The AC method works like this. So I'm going to have 2 other random numbers. They're not actually random. They have a purpose behind them. They're called D and E. And D and E, we find them because D plus E should equal this middle number B, and D times E needs to equal A times C. That's why it's called the AC method. Because usually you start at this spot. A lot of things can add up to BB, but it's better to find the factors of A times C. I think you guys are pretty common with doing this when A is just 1, finding a number that adds to or multiplies to C and adds to B. So that's just the first step of the AC method. And then I'm gonna work through a few examples. I'm gonna replace B right here with D and E, D plus E. So I'm gonna have like A squared. Oh, sorry, not A squared. AX squared plus D plus EX plus C. It's gonna be like AX squared plus DX plus EX plus C. And then we're going to factor via grouping, just like we did before, right? I have 4 terms now. So I can either group these together, or I can group AX squared with EX or whatever. And that's how it works, all right? I actually do this method when the number in front of X squared is not 1. And yeah, all right? So eventually with practice, this method, if you choose to keep going on it, you don't have another fun one to do it. You can do it in your head, but from now, right now, we're just gonna write out all the steps, right? So I like to write out all my letters. So for example, 1, we're asked to factor the following expressions using the AC method. If I ask you to factor something using a specific method and you do it your own way, that problem is wrong. I'm asking you to do it a specific way. I'm asking you to show me that you know how to use this tool. So I expect if I ask you to do something using this, you need to use that. It's like, can you go fill up this with my cup with coffee and you come back with water? I'm going to be like pretty sad if I wanted coffee, you know? So for number 1, we're given 2x squared plus 5x plus 2. Looking at this, I actually have no idea what the factor is. I don't even have my notes up. So I'm going in this blind. So A is going to be 2. B is going to be 5. And C is going to be 2. So I want D plus E to equal just B, just 5. And I want D times E to equal A times C. So 2 times 2 or 4, right? So what are some factors of 4? What are two numbers that I can multiply by to get to 4? 4 and 1. And we also have 2 and 2. And I can switch them like 1 and 4. Right? And then I'm going to narrow my selection pool down by figuring out which one of these satisfies d plus e equals 5. And 2 plus 2 is again 4. That's not 5. So 4 and 1 are my winners. Right? So 4 plus 1 equals 5. And it doesn't matter which one is D and which one is E. It'll just make your grouping a little different, but it won't in the final answer. So let's call D 1 and let's call E 4. How's that sound? All right. So that was step 1. I should have given myself a little bit more room. Did I give myself room later on? Nope. Good job. Okay. So now I'm going to replace B with D plus 1. I'm going to erase factors of 4. We don't really need that. So we'll call that step 1. Step 2. Replace B was D plus E. So I'm going to have 2x squared plus 1 plus 4x plus 2, which is going to equal 2x squared plus x. You can also call it 1x. It's the same thing. Plus 4x plus 2. The great thing about this method, it doesn't matter what D or E are, and your groupings will follow along how they did in example 1, where I can just group the first 2 together and the second 2 together. I haven't seen a time where it hasn't worked doing that way. So yeah, cool. So now we're going to factor via grouping. We already talked about this is my first group. This is my second group. What is the greatest common factor of the first group? 2x plus x, right? It's just x. So I'm going to pull an x out and I'm going to be left with 2x plus 1. Plus, what is the greatest common factor of 4x plus 2? 2. Great. Thank you, Griffin and Jared. You guys are great. Okay. So I'm going to pull 2 out. 4x without a 2 is going to give me 2x plus 1. Woohoo! That looks good. So now I have a 2x plus 1 in each term. So that is now my greatest common factor. So I have 2x plus 1. When I pull that out of my first term, which is this one, I'm going to be left with an x. My second term is this guy, and I'm going to be left with a 2. And there you go. How do you guys like that? Yeah, I know. I understand it not being your favorite. People last semester were up in hands. They did not like it. But it's part of the course curriculum. I have to teach it to you, right? This is a method that, and same with grouping, that if after reading the textbook and talking to me and you just want some, say it's like 2 a.m. and you're doing your homework, don't do your homework at 2 a.m. This is something I would recommend, like going on YouTube and seeing if Khan Academy or like something else has a fun video. Thank you, Hannah Jane. You guys will get through it. All right. There's definitely more things out there that after like maybe like 100 problems, you're like, I still don't really understand an easy method. I think you will by then though. Okay. So who can tell me for problem 2, which is 6x squared minus x minus 12? What is A, B, and C? Let's do a different color. Someone give me their favorite color. So Chloe said blue. Is that a good blue? I also have this other blue that's kind of nice, but it's like a steel blue. I think it's too light. I think it's too light. Let's go with the last one. All right, cool. Ah. All right, so now we're doing this one. I'm gonna underline it in blue so we know we're talking about it in blue. So what do you guys think A is? A is gonna be 6, absolutely. What is B here? Right, it's -1. Remember, A, B, and C, they don't have anything with X. They're just the numbers that are out front of X squared, X, and that constant. All right. That's a little confusing. I have plenty of practice as I am getting a PhD, but it's not always common to see 2 letters multiplied by each other. All right, and C is -12. I see it a lot when that people leave out the negatives, and that will ruin everything. Negatives matter. Do not ignore them. Okay? If you forget a negative, it will ruin everything, and you will be like, it's not, I can't factor it. It is. You just drop your negative along the way. All right, just go pick up your pen, your negative, and put it back in. All right, cool. So step 1, I want to find D and E. So D plus E should equal, what should it equal? Make sure you guys are reading your notes. Right, it should equal -1. And D times E should equal, careful, Abby. Yeah, -72. Drop your negative friend already. Right? Right, -72. So, let's look at factors of 72. Sorry, excuse me, -72. Don't be sad, you got your friend back. All right, cool. So factors of -72. Well, it's divisible by 2. Would that be 36? 2 and 36. That's kind of silly. Oh, one of those is negative. Because I kind of looking for when they add together, there's a -1. 72 came from, remember D times E is supposed to be A times C, the AC method. So 6 times -12, which gave me -72. No, thank you guys for asking. I should have been more clear. So I already know I don't want -2 and 36 because those adding together aren't going to be -1. So I want 2 factors that are kind of close to each other. So what are some other fun factors of 72? -72, other than 6 and 12. We know that one. 6, -12. -6, +12. Once there's a negative, there's like more. Griffin's onto it, -1 and 72. Not an option though. I mean, it is an option. So Ronald gave us -8 and 9. Remember, if the 2 numbers add up together and they equal 9, they're divisible by 9. Oops, -8 and also 8 and -9. So this is where finding D plus E equal to -1 will make or break your answer. If you drop that -1, you'll get a completely different D and E. One will be negative when the other one should be. So when I add these two numbers together, I want to get -1. So if I do -8 plus 9, which is also 9 minus 8, I get a +1. But if I do 8 plus a -9, I get a -1, which is what I want. Right? So 8, -9 is our correct set. Ding, ding, ding. So I'm going to erase all of our factors just because they were in my way and I didn't give myself enough room. So let's make D 8 and E -9. All right. Step 2 says to replace that negative right there with D plus E. So I'm going to have, oops, 6x squared plus, because remember that negative right there came from -1, but I'm replacing that with 8 minus 9x. So that negative goes away. Minus 12, that one can stay. And then I'm going to distribute my x. So I get 6x squared plus 8x minus 9x minus 12. Great. And the benefits of this method is our groups are already smushed together. Yay. So I'm going to group 6x squared with 8x minus 9x. Oops. When you have things with negatives, it's just safe to put a negative right there and then group the negatives in. And I just think it'll be more trouble to put, but they're both negative, so you could pull the negative out, but you need to pull the negative out of both, and it's just a lot of things to remember. So just be careful with that. Minus 12, okay? It would be incorrect to write it like this because then you would think about that negative distributing to a -12. That's kind of what I'm saying. Okay. So now I've picked my groups. I need to find the greatest common factor of each of my groups. So 6x squared plus 8x. What is the common factor? 2x. Both of them are even, so 2 is probably going to be one of them. 2x. And then if I pull 2x out, I'll get 3x squared plus pulling an x out, and then 8 divided by 2 is, oops, 4. Oops, I added an x squared. I got so excited. Right? Beautiful. What about minus 9x minus 12? Ronald has run. Ronald, too fast. Okay, Abby and Ronald are now out of the race for today. No more answering questions. No, you guys are just speed demons. I want other people to have chances. I know. There's nothing wrong with taking your answering tickets away. Okay, so it's going to be -3, right? I have, first of all, both of them are negative. So that's a great sign that I should pull out a negative. So I'm just going to add it right there. Or include it, I shouldn't say add. And then 9 and 12, we can see are divisible by 3. So I'm going to pull out that 3 as well. So I'm going to be left with 3x plus 4. Great. And you know you're kind of on the right line when we get up like this. And Jaden did the next step for us where we pulled out the common factor of each of the big terms. So 3x minus 4 and 2x minus 3x. Sorry, minus 3, not 3x. All right. How are you guys feeling with the AC method after that second one? Oh my God, yay, Chloe. Yay. It's definitely very useful. Okay, so I think, okay, cool. We have like 10 more minutes in class. A 7 out of 10. It's a valid answer. So we have 10 more minutes of class. It takes us like 3 minutes to do an exit slip. So I'm going to give you guys like 3. I'll give you like 4 minutes to do example 3. And then we will discuss afterwards. All right. So no giving hints in the chat. I'm watching you. Try the AC method. And if you're not sure and you have another method, you can always double check with it. But try the AC method on your own and then we will discuss. All right. Go. So there's A, B, and C. You have like another minute and then we will discuss. Alrighty. So who can tell me what they did in step 1? You turn on your mic or you can type and I'll give you a little bit of time to type. I've already written A, B, and C up top. Oh, I'm freezing a little bit. So Chloe found factors of 45, right? So I want D plus E to equal what, -14, and D times E to equal 3 times 15, which is 45. Did I do this right? Okay, cool. Alrighty. So what are some factors of 45 that you liked, Chloe, and why? Nine and 5. Those were good ones. But what do they add to? They add to positive 14. Well, careful, Tucker. 9 times -5 will give me -45. And we'll add to, yeah. So I want to make both of them negative. Tricky, tricky. Jane's got the right idea. So even though finding 9 and 5 was really close, -9, -5. You could have gotten away with doing just leaving the minus out and doing 9 plus 5. You just had to do a little bit more distributing. So great. So let's call D -9 and E -5. So I'm replacing B, which is -14, with -9 plus -5. So I have 15x squared plus, remember, because that negative was attached to the -14, -9 plus -5x plus 3. What I was saying, while 9 and 5 wasn't completely incorrect, is you could have done something like this if you decide to leave the negative out, right? But it just needs to be clear that, to me, if you're showing me this on your homework, that if you choose 9 and 5, that you're leaving this negative out. Yeah. Good job, Chloe. Plus 3. Great, and then both times we will get 15x squared minus 9x minus 5x plus 3. Great. Did anyone group them like this? 15x squared minus 9x. And then I'm going to put a plus here, minus 5x plus 3. Right? So I grouped them together. Now what do I do? You can finish this in 2 minutes. Right, I want to pull out my greatest common factor. Jane, what is that? For each of these, right? 3x, so 15x squared and minus 9x. Pull out a 3, I'll be left with 5x minus 3 plus, what would you pull out of this factor? Yeah, we're going to pull out the -1. You might think when you group this together, you'd be like, oh, 5x and 3, there's nothing really in common about them. But seeing that when I pulled out 3x here, I got 5x minus 3, I want to make it look like that. So I'm going to pull out a -1, and that flips the sign of everything. So -5x becomes a positive 5x, and plus 3 becomes a minus 3. And because I saw that pattern of making this one going to look like this guy, I knew what to do. So now I need to factor by pulling out the greatest common factor. I'm going to pull out 5x minus 3 of each term of the large terms. And so I'm going to be left with 3x minus 1. Beautiful. Thank you, Chloe. Oh my gosh, right on time. I think how much? Yeah, and then we have a little bit more that we're going to talk about next class. All right, cool. So this will be covered on your homework. Now time to do exits up really fast. Socrative. The room, BLACK 943. And the teacher question of the day is, trying to think of one. Does anyone have a good question of the day? Oh yeah, that's a good one. Thank you, Ronald. What do D and E in the AC method? Like what equations do they need to satisfy? Right? Remember to do last name, comma, first name. I think both of you guys are like kind of doing that now, which is like awesome. So please do that. And then once you're done, you guys are good to go. And I'll see you on Tuesday. I'll be sending out an email when homework is up for you guys. In the meantime, I'm going to stop recording.